Right, I'm just going to go over some multiple choice that a few of you have been finding difficult. So the first one is this question 3 on normal water and heavy water reacting together. And we want to look at how the temperature varies with, how the yield varies with temperature. So what we need to realize here, so when we think about equilibrium, so if the forward reaction is exothermic, then the percentage yield, so we're increasing the temperature. So when you increase the temperature, the percentage yield will go down. That's because of the French guy's principle. So if it's increasing the temperature, it's going to try and decrease the temperature, so it'll go to the left. So if the forward reaction is endothermic, then if you increase the temperature, the percentage yield will go up. Okay, so in order to work out which graph we're looking at, we've got to work out whether the forward reaction is endothermic or exothermic. If it was, so graph A, as the temperature goes up, the yield goes down. That would be if the forward reaction was exothermic. If it's endothermic, then when you increase the temperature, so that would be C. And then if you look at graph B, that would be that the forward reaction is neither exo or endo. So in other words, the enthalpy change is 0. Because as you can see, the temperature doesn't affect the yield. So for that to be the case, delta H has got to be 0. So in order to work out which of these scenarios we've got, I've got to draw a Hess's diagram. So if I just write this out quickly. Right, so it's given me the standard enthalpy of formation. So the standard enthalpy of formation goes from the elements. So we've got H2, we've got O2, and we've got D2. I'm just going to put that in a box. So my standard enthalpy of formation of water would be that. So it tells us in the question that's minus 286. It tells us the standard enthalpy of heavy water, which is D2O, is minus 294. And it tells us that of HDO, now remember there's 2 there, so that's got to be 2 lots of minus 290. And I'm trying to find out X. So X is going to be, so I'm going from here to there. So I'm going against that arrow, so I've got to minus it. So it's minus 286. I'm going minus that arrow, so minus 294. Plus 2 lots of minus 290. And if I do the maths on that, that comes out as 0. So because the enthalpy change for that forward reaction is 0, that means we're in scenario B. So it's neither exo or endothermic, in which case we're going to get the yield is not dependent on the temperature, so it's going to be B. Right, so that's the first question. Right, question 4. So that was question 3. This is question 4. These questions are from my website, so if you want to see the actual questions along with the other, they're in the multiple choice section. Right, so question 4. Right, so this is a bit of a long one. So let's draw out the information first. So what's happening is my magnesium hydroxide, so that's my formula, which gives you an equation. It's fully dissociating into ions. So that's going to give me Mg2 plus and 2OH minus. And it gives me the expression for the equilibrium constant as being the concentration of Mg2 plus times by the concentration of OH minus squared, remember, because we've got this 2 here. Now, it does tell you that it contains 0.1166 grams of magnesium hydroxide, so you could do something with that, but we don't need to. It's a bit of a red herring. So it tells us that in a saturated solution at different temperature, the concentration of hydroxide ions is 1 times 10 to the minus 3. So if this is 1 times 10 to the minus 3, so that's the concentration of OH minus. So if you look at this equation, each magnesium hydroxide that dissociates gives 2 OH minus and 1 Mg2 plus. So the amount, and therefore the concentration of Mg2 plus, has got to be half of this. So that's going to be, so half of that is going to be 5 times 10 to the minus 4. So now I can just put these into this equation. So K is 5 times 10 to the minus 4 times by, and I can use round brackets now because I'm just talking about numbers, times by 1 times 10 to the minus 3 squared. And if I stick that into my calculator, I get 5 times 10 to the minus 10, which if we look here is answer D. Right, that's question 4. Right, question 5. So it's another equilibrium one here. So I'm just going to write the equation out, but I'm going to be lazy here. I'm going to go acid plus alcohol gives ester plus water. You don't need to write it out because if you're doing it on a piece of paper in an exam, you've got it there. So I need to work out the equilibrium constant. So I need to do one of these tables where I say start, change, and equilibrium. So let me just draw some lines. Apologies for the messiness. Right, so if I look in the question, so if I look here, it says 3 moles of ethanoic acid at the start and 1 mole of ethanol at the start. And it doesn't say about the ester or water, so I'm assuming that's 0. And then it says at equilibrium, 0.9 moles of water is formed. So at equilibrium, I've got 0.9 now. So if I had none there and it's gone up to 0.9, it's gone up by 0.9. And if I look at this equation here, if I make 1 water molecule, I'm making 1 ester. So if the water's gone up by 0.9, the ester's also gone up by 0.9, so that's going to be 0.9 at equilibrium as well. And if I look here, 1 alcohol, if I look in the proper equation that's in the question, 1 alcohol and 1 acid react together to make 1 ester and 1 water. So if the ester's gone up by 0.9, the alcohol's gone down by 0.9 and the acid's gone down by 0.9. So 1 minus 0.9 is 0.1, 3 minus 0.9 is 2.1. So these are my number of moles at equilibrium. Now, if I'm doing this properly, I would divide by the volume and I can just put V in the equation. However, I can cheat here because I can see that I've got the same number of moles on the left as on the right, so the volume is going to cancel. So because it's a multiple choice question and I don't need, my marking's not going to be affected here, I just write Kc, so it's going to be the concentration of the ester over the water divided by, times by the water over the concentration of the acid times by the alcohol. So that's going to be, if I look at my table, 0.9 times by 0.9 over 2.1 times by 0.1. And if I stick that in my calculator, that gives me a figure of 3.9, which is C. So that's the first C on there, because you can see that the second C should actually be a D, but there's a mistake in the exam question. So question 5 is C. Right, on to the next question. Right, question 7. So, organic compound is found to contain 40% carbon, 6.7% hydrogen, and 53.3% oxygen. So what I need to do here, it's an empirical formula calculation. First thing I do is divide by, so I'm going to put the carbon there, the hydrogen there, the oxygen there. First thing I do is divide by the relative atomic mass of the element. So if I look in the periodic table, carbon's 12, hydrogen is 1, so that's 6.7 over 1, and oxygen is 53.3 divided by 16. So if I stick that into my calculator, I will get 3.3. That's obviously 6.7 because I'm just dividing by 1. If I stick that into my calculator, I also get 3.3. Then I just need to divide by the smallest number. So divide that by 3.3, that by 3.3, that by 3.3. So that gives me 1, 2, and 1. So that gives me an empirical formula of CH2O. So now I've just got to look at what I've got in the question and work out the empirical formula of those. So A would be ethanol. So ethanol is CH3, CH2OH. So that's going to be C2H4O. And I can't simplify that any further because there's only one oxygen. So it's not A, because that's not the same as what we've worked out. Right, if I go to B, so I go to ethanoic acid. So ethanoic acid is this. That's my molecule drawn out. So if I work out the molecular formula of that, that's C2H4O2, because I've got 1, 2, 3, 4 hydrogens, 2 oxygens, 2 carbons. And if I write the empirical formula of that, I've got to divide by the highest common factor, which is 2. So that will give me 1 carbon, 2 hydrogens, 1 oxygen. And that happily, I say happily because now I don't have to work out C and D. Although in an exam situation, if you've got time, it's probably a good idea just to check you've not made a mistake. So therefore, that's the correct one. So B is the correct answer. Right, 8. This is quite a tricky question. So if we look at 8, it wants to know which has got the most chloride ions. So and what I need for this, I need to remember number of moles is concentration times by volume. So I've got to look at all of these, and first of all I need to write out what the formulas are. So A, so ammonium chloride is NH4Cl. Calcium chloride, so I've got to remember here that calcium's in group 2, so the formula of that's going to be CaCl2. C, the hydrochloric acid is HCl. And D, sodium chloride, sodium's in group 1, so it's just NaCl. So all I've got to do is work out the number of moles of each of those is concentration times by volume. So for ammonium chloride, that's 3.4 times 10 to the minus 2 times by 15 over 1,000. The calcium chloride, because there's 2 chloride ions, each mole of calcium chloride is going to give me 2 chlorides. So I need to times this by 2. So that's going to be 2 times 30 over 1,000 times by 5.5 times 10 to the minus 2. And HCl is going to be 2.3 times 10 to the minus 2 times by 40 over 1,000. And NaCl is going to be 2.2 times 10 to the minus 2 times by 45 over 1,000. Right, so if I do those, then the one that comes out the most is B. So this comes out as the biggest number. So therefore the answer to question 8 is B.